And our success criteria is to identify the horizontal asymptotes and evaluate the limits of rational functions at infinity through real-life examples. For example, to determine the size of the pupil with an infinite amount of light by evaluating the limits of rational functions graphically and numerically. But in this part, we will study about graphically. So, infinity. What is infinity? The 8, yani the symbol like this 8, which is which is lying horizontally, is said to be infinity, and it means, if it is positive infinity, it means at that a very large numbers. Okay, means you know that if here it is 0, so on the right hand side for the x-axis the numbers are increasing, right? So when the numbers are increasing on the right hand side and become greater and greater and greater, it means they are reaching towards the positive infinity. Similarly, on the left hand side, you can see that the number decreases, right? So the numbers are decreasing on the left hand side, starting from 0 to onwards. Okay, so they are moving from right to left. Okay, so if they will start decreasing, so they reaches to a very small number. So in short, positive infinity represent very large number and negative infinity represents very small number. Now, if we are writing limit x approaches to infinity f of x for the function f of x is equal to a number. Okay, so this is the way to represent the horizontal asymptote. Similarly, we can also write limit x approaches to negative infinity for the function f of x equals to L. This means that we are talking about the left hand side limit. Look at this one. Okay, so here it is our 0, right? On this side of x, on the left side of x, the numbers are expressed by negative infinity. Similarly, on the right hand side of the x, we can say the numbers are represented by the positive infinity if they are very large. So, if you remember that we have studied, let's suppose this is my, let me write a graph. Let me make a graph for you like this, okay? So you can see a graph. Now, horizontal asymptote is shown here, right? By this dotted line and by this dotted line. There is no vertical asymptote we can see over here right now. So now let's see here. Let's look at this one. If I ask you what is the limit x approaches to for the function f of x when x is approaching to negative infinity. So you know that in previous grades we have studied and we have expressed or we have found the end behavior. So end behavior can be given by when x is approaching to positive infinity, what is the behavior of the y. So similarly, when x is approaching to negative infinity, what is the behavior of the y. Now look at the graph. Here it is negative infinity. So if this is negative infinity, so look at this one and let's suppose here 2 and here it is negative 3. So what is the value of the y? Approximate, if you see, the value of the y is positive 2. Okay, so the value of the y on negative infinity is positive 2. Now, what is the end behavior of the function when limit of a function f of x when x is approaching to positive infinity? So look at the graph. Here positive infinity. Okay, so look at the graph. What is the y value? So here the y value is negative 3. Which means that when x is approaching to the positive infinity, the value of the y is negative 3. Now the horizontal lines are representing over here, the dotted lines are representing the horizontal asymptotes. So the important thing is when x is approaching to the positive or the negative infinity, it means that we are representing our horizontal asymptote. Whereas to determine the vertical asymptotes, we express the limit, that limit x is approaching to a from the left side or limit x approaching to a from the right side. Whereas what is a? A is a number. Okay, so from the left side and the right side, it could be positive infinity or negative infinity, or from the right side also it could be positive or negative infinity. What is the difference between these two things? That in horizontal asymptote, the x is approaching to a positive or negative infinity, whereas the y value is a number. Whereas in vertical asymptote, the x is approaching to a number, whereas the y value is infinity or negative infinity. Look at the graph and can you write the expressions, or can you write the limit equation to express this graph? Yes, I can write it. How will I write it? Let's suppose this is -1 and this is +1. How can I write it? The first thing I will write limit of a function f of x when x is approaching to negative infinity. And one time I will write limit of the function f of x when x is approaching to the positive infinity. Now negative infinity on this side, right? So where is the graph? Here is the graph. So read the y value, come here, approximately equals to -1. Similarly, here is positive infinity. Where is the graph? The graph is here, right? And if you want to read the y value, it will be approximately equals to 1. There is no vertical asymptote, so no need to express this graph by showing any limit expression that could give you the vertical asymptote. Now look at this graph. Okay, so similarly here negative infinity, right? So this is the graph. Now we will not read the x value, we will read what is the y value. The y value when x is approaching to negative infinity is equals to 2. Now on the positive infinity read, let's suppose limit x is approaching to positive infinity. The y value, it is the graph, right? The y value is equals to -1. Let's read this graph. Now, can you see that here there is a vertical asymptote also, but here they are not asking us to give the vertical asymptote, but let's see. So when x is approaching to negative infinity, so here is the negative infinity. Where is the graph? I can see here the graph. Don't see here and there, just this is the graph. Read the y value, approximately equals to +2. Now when x is approaching to positive infinity, so here is the positive infinity. Where is the graph? Here is the graph. Read the y value, approximately equals to 0. Now here look at the graph. Limit x is approaching to negative infinity. So on this side, negative infinity. Read the graph. What is the y value? It is approximate equal to 0. When it is positive infinity, where is the graph? Here. What is the value of this y? It is -1. Now, although this is not a question, but can you write the limit equation for the vertical asymptote? You can see that here is the vertical asymptote, right? Here is the vertical asymptote. Means on the one, there is a vertical asymptote. Let's see here. Let me just erase this part so that we can see here. Okay, so here is the vertical asymptote. So where? On the 4. So how do we express the vertical asymptote? For vertical asymptote, always the number x is approaching to some number. So it is 4 from the left side and 4 from the right side. Why 4? Because on the 4 I can see a unbounded behavior of a graph. Which means now left side. Look at this on the right, on the line, just put two hands here. Let's see here, you have this hand here, okay, and one hand over here, okay. Hide everything, yani hide this part, hide this part. Now see there, this is left side, this is right hand, right? So left line going where? Going towards sky. So it means, so left 4 from the left side, answer is positive infinity, and 4 from the right side, again the graph is going up, which means it is positive infinity. One more equation we can make, limit x approaches to 4 from both sides. So both sides are going towards the sky, so plus infinity is the answer. Okay, so evaluate the vertical and the horizontal asymptote. So look at this graph. So we will have only horizontal asymptote, right? This is only horizontal asymptote. No vertical asymptote is shown. So one time we write limit x is approaching towards the positive infinity and one time towards the negative infinity. So positive and negative infinity, the y value is 0. Positive infinity, the y value is also 0. Now look at this graph. So first we will always write limit x is approaching to negative infinity and one time to the positive infinity. Okay, so when we look at the negative infinity here, end behavior, for positive or negative infinity, we don't go see anywhere. We just see where is the ending of the graph. So you can see the ending of the graph is going down, which means negative infinity. Now when x is approaching to positive infinity, the ending of the graph from the right side is going towards the sky. So it is positive infinity. Now can you see that there is a vertical asymptote at -1? So write the three equations. Limit x is approaching to -1 from the left side, from the right side and from both sides. Okay, left side means now hide the graph in such a way that only vertical asymptote is shown. Okay, so here, so this is left side and this is right side, and this dotted graph, this dotted line is actually in between. So left side where the graph is going, you see the graph is going down, left side. So it is negative infinity. And on the right side, if you see closely, the graph is going up, which means positive infinity. So from both sides, the limit does not exist. Evaluate the limit and sketch the graph. Okay, so first of all, evaluate the limits and sketch the graph. So let's sketch the graph. Go to the graphic calculator. On the graphic calculator, menu, then graph, and then y equals to, write the equation, only this equation. So you have to write 2x square over x square minus 4 in the graph. Make sure that in the graphic calculator there is a cursor on the second line, black color, x theta is written on that. So in order to write the x value, only press this button. So here is the graph. Okay, so limit x is approaching to negative infinity. So negative infinity is here, right? So where is the graph on the negative infinity? You will see here. That means it is equals to 2. Now limit x is approaching to positive infinity. So what is the end behavior of the graph? The graph is going down. That means negative infinity. Now can you sketch the graph showing these conditions? Whenever anyone asks you to graph showing certain conditions, so first of all you label the graph coordinates. Okay, so here it is my positive infinity, here y positive infinity, here x negative infinity, and here y is negative infinity. Okay, when x is approaching to negative 3, the y value is 3. So 1, 2, 3. Y value 3 means there is a horizontal asymptote. So you can make any kind of graph which gives you a horizontal asymptote at 3. So look, on the 3 there is a horizontal asymptote. So I can go like this, okay, just to represent. Okay, this is my half graph. Now there is another condition that x equals to 5. X is approaching to the 5 here. Yani x value is 5. The y value is positive infinity. So it means that I have a vertical asymptote. So I will join this graph, and because it is positive infinity, so I will make like this. Now they are saying when x is approaching to positive infinity, the y value is negative infinity. But have you seen this thing also, that here it is saying x is approaching to 5. Not from the left, not from the right, but from both sides, the answer is positive infinity. Whereas when the graph is reaching to, so positive infinity, we will graph on the right side, I make like this. But also they are saying that when it is approaching to positive infinity, the y value is negative infinity. So I can make like this, okay, because the graph is going to the downward side. So I can make any kind of the graph to show these conditions.